Look at your hand. Go ahead. I'll wait. Look at it right now. It's solid, right? You can feel it. If you make a fist, there's something substantial there. Your hand is a thing, a real solid thing. You could hold it up and a blind person could feel it and say, yes, that's a hand. That's a solid object. And you'd both be absolutely certain of it. And you'd both be, from a certain perspective, completely wrong. Let me explain why that bothers me so much, that I've spent years thinking about it. When you look at something, when you really look at it with your eyes, what you're actually seeing is light bouncing off it, photons hitting the surface of your hand, bouncing back to your eye, creating the impression of solidity. Your eye is incredibly good at this job. It's been refined by millions of years of evolution. Your brain has learned to interpret the pattern of light hitting your retina as objects with shapes and positions and substance. But your eye is also lying to you in the most fundamental way, because the solid surface you're seeing doesn't exist. Not in the way you think it does. Here's the thing. Atoms are mostly empty space. I want to emphasize that word. Mostly. Let me give you a thought experiment. Imagine the nucleus of an atom, that incredibly dense little thing in the center. Imagine it as a marble. Not a tiny marble. Not a marble you could hold between your fingers. Imagine a marble about the size of an apple. That apple-sized marble sits in the middle of your hand. Where are the electrons? The electrons are not close to the nucleus. The electrons are orbiting that apple-sized marble, but they're orbiting at a distance of about 200 meters, about the length of 2 football fields. The electrons are that far away. The space between the nucleus and the electrons is essentially empty, just empty space with forces crossing through it. And yet somehow this system, this apple-sized nucleus surrounded by electrons 5 football fields away, this system is what we call an atom. This is a single atom. And atoms are what everything is made of. Every single atom around you, in the universe. So your hand, which feels so solid, which looks so real and substantial when you hold it up to the light, which resists when you push it against something, your hand is mostly the empty space between nuclei and electrons. Most of the volume of your hand is empty. There's more nothingness in your hand than there-ness. If we could somehow remove all the empty space from the atoms in your body, if we could squeeze you down to just the nuclear matter, compacting nuclei together until they're all touching, until they can't be compressed anymore, your entire body, your whole self, everything you weigh, everything that makes you you, would compress down to something about the size of a sugar cube, maybe a little bigger, a marble perhaps, a piece of matter so dense that if you held it in your hand, it would be heavier than a car, denser than anything on Earth, denser than anything we can easily make in a laboratory. It would fall through the ground. It would keep falling until it came to rest at the center of the Earth. But that's not really the thing that should bother you about this fact. The thing that should bother you is how you're still standing here, feeling solid, feeling real, with your hand in front of your face, even knowing that you're mostly empty space. You see, I think there's a deep confusion in human beings about what solidity means. You touch something, and it feels hard, and you think that hardness is a property of the atoms in it, that atoms themselves are hard things that can't pass through other hard things. But atoms aren't hard. Atoms are not hard at all. Atoms are just patterns, patterns of forces, patterns of charge. The nucleus in the center is positively charged, and the electrons around it are negatively charged, and opposite charges attract each other. But the electrons aren't trying to fall into the nucleus. They can't. Quantum mechanics forbids it. The electrons have to maintain a certain distance. They have to stay in their allowed orbits, in their allowed energy levels. If you tried to push an electron closer to the nucleus, you'd have to give it energy, and there's no lower energy level available, so you can't. The electron is stuck at a certain distance. It's held there not by walls or barriers, but by the fundamental laws of quantum mechanics. And this is where the solidity of your hand actually comes from. It doesn't come from atoms being hard little balls. It comes from the fact that the electron clouds around neighboring atoms can't occupy the same space. They repel each other. Electromagnetic repulsion. One atom's electrons pushing against another atom's electrons. And because this repulsion is very strong, very real, and happens almost instantaneously across very tiny distances, we experience it as solidity. We experience the repulsion of electron clouds as the sensation of touching something hard. The wall is hard because electron clouds can't overlap. So when you hold your hand in front of your face, when you feel it there, real and solid, what you're actually feeling is the electromagnetic repulsion between your hand and your face. You're not touching anything. You're being pushed away by forces. You're not in contact. You're about 1/10 of a nanometer away from anything solid, and forces are keeping you there. A nanometer is 1/1000th of a meter. 1/10 of a nanometer is 10 billionth of a meter. That's 0.000001 meter. That's the distance you're actually maintaining between your hand and your face while feeling like you're in contact. You're actually separated by the tiniest possible distance, and forces are keeping you apart. Electromagnetic forces. The same forces that hold atoms together are preventing you from ever actually touching anything. This is something that really bothered me when I first learned it. Here I was, thinking I lived in a solid world, solid ground, solid walls, solid people, but in fact I was living in a universe of empty space and forces. I was walking on a surface that was 99.999% emptiness, held together by electromagnetic repulsion, and experiencing that emptiness as solid ground. When I shook someone's hand, I was being held at nanometer distance from them by electron cloud repulsion. I was never really touching anyone. We were all just pushing on each other with invisible forces. Let me give you some numbers so you really understand the scale we're talking about, the scale of the emptiness, the nucleus of an atom, just the nucleus, just the protons and neutrons packed together as tightly as physics allows, is about 100,000 times smaller than the atom itself. More precisely, if the nucleus were the size of a period at the end of a sentence, the atom would be the size of a concert hall. The nucleus would be one tiny period sitting in the middle of an enormous concert hall. That's the scale. And yet almost all the mass of the atom, about 99.9% of the mass, is in that tiny period in the middle. Almost all the mass is in the nucleus, and almost all the volume is in the empty space. The atom is almost entirely space. You are almost entirely space. So the question I want you to sit with is, what is the atom really? Is it the nucleus, which is tiny but massive and dense? Or is it the electron cloud, which is enormous and fuzzy and spread out? We say an atom is the whole thing together, nucleus plus electrons, but the electrons are so small and so far away, and there's so much empty space between them that it's like saying a solar system is an object. The sun is in the middle, the planets are orbiting around it, there's vast empty space between them, and somehow that's a system, that's a thing. But the solar system isn't really a thing the way a marble is a thing. It's a system, a configuration, a relationship between objects, and so is an atom. Now, you might think this is just interesting, just an odd fact about how nature is organized at the very small scale. But here's the thing that really gets me. The reason we experience atoms as solid isn't because they are solid. It's because the forces between them are strong enough and they respond fast enough that we can't push through. If we had direct access to the electromagnetic force, if we could somehow control it at the atomic level, we could walk through walls. We could walk through each other. We could walk through the ground and fall through it into the magma. We experience solidity, not because solidity exists, but because electromagnetic repulsion is fast and strong. It's fast enough that our hands bounce off things before the atoms actually touch. It's strong enough that the repulsion is overwhelming. But at electromagnetic force, not solidity. The wall in your house isn't solid. It's just a configuration of electromagnetic forces so strong that you can't push through it. That's all solidity is. That's the entire explanation. This used to bother me when I was younger. I thought the world was a kind of deception. I thought that learning about atoms and electrons and forces meant understanding that my experience was wrong, that the solid world I lived in was an illusion. But then I realized something. I realized that forces are real. Electromagnetic repulsion is real. The strength of those repulsions is real. The fact that my hand bounces off a wall is real. The solidity I feel is real. It's just not what I thought it was. It's not the atoms being hard. It's the forces being strong. The solidity is not a deception. It's a consequence of forces. So solidity isn't an illusion. It's just a consequence of forces, of the interaction of one electromagnetic field with another. And forces are just as real as anything else in physics. More real, actually, in a certain sense, because forces are what actually determines how things move, how things interact, how the universe evolves. The atoms are almost incidental. The forces are what matter. Let me think about this more carefully, because I want to explain it the way I would explain it to myself when I'm confused. You see, we have this habit of talking about solids as if they're a fundamental category of matter. We divide things into solids, liquids, and gases, and we think of those as different states of being. But really, they're all the same thing. They're all just atoms, arranged differently, interacting with different forces. A solid is atoms held in fixed positions relative to each other by electromagnetic forces. They vibrate in place, but they stay where they are. A liquid is atoms that can move around each other relatively freely, but they're still held together by weaker electromagnetic attractions. They can flow, but they don't escape. A gas is atoms that are flying around, mostly independent of each other, rarely interacting in any significant way. But it's all atoms, it's all electromagnetic force. The only thing changing is the arrangement and the strength of the forces holding them together. And now here's the weird part. Here's the thing that really gets me. If you take a solid, let's say a block of ice, and you add energy to it, heat it up, give those atoms more energy to move around, you can turn that solid into a liquid, water. The atoms are the same, the forces are the same, but now the stuff is no longer solid. It flows, it takes the shape of its container. It's pourable, it's fluid, but the atoms haven't changed. The electromagnetic forces between them haven't changed. What changed is that the atoms have more kinetic energy, more energy of motion, so they're moving faster and can escape from fixed positions more easily. Add more energy, more heat, and the liquid becomes a gas. The atoms are moving so fast that they're no longer attracted to each other at all, or the attraction is so weak that it doesn't matter. They're just flying around, bouncing off each other, flying apart. But again, the atoms are the same, the forces are the same, only the energy of motion has changed. So what is a solid really? It's not a category of being, it's not a fundamental state of matter. It's just a temporary arrangement of atoms that happen to have lost enough energy that electromagnetic forces can hold them in place. It's a configuration, a pattern, a dance that the atoms are doing, and the dance is slow enough and orderly enough that we experience it as solid. But if you add heat, if you add energy, the dance speeds up, becomes chaotic, and the solid melts. Now, imagine an even more extreme case. Take all the atoms in your body, all 70 kilograms of you, more or less, and imagine we compress them together. We take all the empty space out, we push the electron clouds until they overlap and can't overlap anymore. We push the nuclei until they're touching. What happens? Well, first, the electrons would form a degenerate state. They'd be forced into higher and higher energy levels because they can't all occupy the same quantum state. This is called electron degeneracy pressure, and it's incredibly strong. It's what holds up neutron stars, the remnants of dead massive stars. The pressure from electrons forced to occupy all these different states is enough to support the weight of a star against its own gravity. It's an enormous force, but if you keep compressing, if you keep adding pressure, even that gives way. The electrons get pushed so hard that they combine with protons and form neutrons. The nuclei themselves start to fuse. The matter becomes more and more dense. And if you compress enough, if you add enough pressure, the nuclei collapse entirely into a black hole. That 70 kilograms of you becomes something smaller than an atom, smaller than a nucleus, a thing so dense that even light can't escape from it. That's what happens when you try to remove all the empty space. That's the other end of the scale. Your body, compressed to the point where the empty space is completely gone, all those electromagnetic forces turned into gravitational effects, becomes a black hole about the size of a grain of sand. Actually much smaller, much smaller, roughly 1 part in a trillion the size of a grain of sand. You'd have to have an unimaginably dense object, invisible, pulling with incredible gravity, but the mass would be the same. Your actual mass wouldn't change. You'd just be arranged completely differently. This is a good moment to step back and admit something. I don't fully understand why the universe is set up the way it is. I don't understand why electromagnetic forces are strong enough to create stable atoms, why atoms are held together by forces rather than by some kind of intrinsic solidity. I don't understand why electrons have the mass they have, why they resist being compressed the way they do. There's something about the fundamental structure of quantum mechanics that gives rise to what we call solidity, but I don't have an explanation for why that structure is there. I can describe it, I can predict its effects, but I don't understand it at the deepest level. Let me try to make this concrete again, because I think we get lost in abstractions and forget what we're talking about. Your body is made of cells. Each cell is made of molecules. Each molecule is made of atoms. Each atom is made of a nucleus and electrons. The nucleus is made of protons and neutrons. The protons and neutrons are made of quarks held together by gluons. And where does it end? Does it end? Do quarks have parts? We don't think so. We think quarks might be fundamental. We're not sure. But what we do know is that all the way down this chain, at every level, the solidity is a consequence of forces, not of intrinsic hardness. All the way down. Your hand, when you look at it, appears to be one unified thing, one continuous object. But it's not. It's roughly 10 to the 28 atoms held together by electromagnetic forces. That's 10 billion atoms, each one of them mostly empty space, each one of them existing because forces are strong enough to hold them together. Your hand is a pattern, a configuration that persists because the forces maintaining it are strong. Here's a thought that might sit with you. When you were young, you probably thought the world was made of solid objects. Rocks are solid, wood is solid, metal is solid. As you grew up, you learned that's not entirely true. You learned that matter is made of atoms. But then you probably thought atoms were little solid objects. And now you're learning that atoms aren't solid either. They're mostly empty space and forces. But here's the thing. Maybe there's no bottom to this. Maybe we keep going deeper and deeper and finding that everything is empty space and forces all the way down infinitely, and solidity is just a name we give to a pattern that emerges at the scale where we perceive things. Or maybe there's something at the bottom. Maybe quarks aren't fundamental. Maybe there's another layer beneath quarks, and another beneath that, like an infinite fractal, and we'll never reach the bottom. Maybe the universe is infinitely deep in that way. We don't know. But what I want you to understand, really understand, is this. The experience you have of living in a solid world is real. When you touch something and it feels hard, that's real. The electromagnetic repulsion is real. The strength of those repulsions is real. The fact that my hand bounces off a wall is real. But the reason it feels hard, the mechanism behind it, that's not solidity in the way you think of solidity. It's force. It's the interaction of fields. It's something more subtle and more interesting than hardness. And that means you're not what you think you are. You're not a solid object made of smaller solid objects, made of smaller solid objects all the way down. You're a pattern of forces. You're a way that quantum fields have arranged themselves in this region of space. You're a stability, a temporary organization, a dance, and most of you is empty. Most of you isn't there, if there means matter. Most of you is the space between particles and the forces crossing through that space. Most of you is interaction and relationship and force. And yet you're definitely here. You're definitely real. You're definitely solid enough that you can push a hand against a wall and feel resistance. You're definitely substantial enough that other people can see you and touch you and verify that you exist. The fact that you're mostly empty doesn't make you less real. It just means that reality is less solid than you thought. It's more subtle. It's more beautiful. It's more deeply connected to force and field and interaction. What does it feel like to exist as a pattern? What does it feel like to be held together by forces rather than by intrinsic substance? I think it feels like being alive. I think it feels like being aware. Because that's what you are. Not a thing, but a process. Not a substance, but a pattern. Not a solid object, but a structure. Not a dead thing, but something that has meaning only through interaction and relationship. And when you're gone, when you die, that pattern breaks apart. The forces stop holding the atoms in this configuration. The atoms disperse. Some of them go into the soil. Some of them get taken up by plants. Some of them cycle through other living things. The atoms that made up your body get recycled. But the pattern that was you, the organization that made you you, the way those atoms were configured and interacting, that ceases to exist. The atoms don't cease to exist. The matter doesn't cease to exist. But you do. And that's because you weren't the atoms. You were the pattern. You were the configuration. You were the way the forces were organizing the atoms. Think about that the next time you feel yourself being solid, being real, being substantial in the world. You're not substantial in the way you think. You're remarkable in the way you think. You're temporary and made of mostly empty space, held together by forces you don't feel directly, but that are real nonetheless. And the only reason you feel solid is because you're not alone. You're surrounded by other patterns, other people, other objects, all made of the same empty space and forces, all pushing against you with the same electromagnetic repulsion that you're pushing against them with. You're solid because everything else is also empty in the same way you are. And somehow, in the interaction between patterns, in the meeting of forces, in the configuration of atoms around atoms, meaning emerges, consciousness emerges, the ability to wonder emerges. And that's the real miracle. Not that you're solid, but that you're here at all. That the forces that hold atoms together also allow for complexity. That electromagnetic repulsion, this very thing that keeps you from ever truly touching anything, this same thing also allows for chemistry, for molecules, for life. What a strange and beautiful arrangement that is. What an odd accident of nature that produces not just solids and liquids and gases, but thinking beings capable of wondering about their own nature. There's a particular kind of humility that comes from understanding this. When you realize that you're mostly empty space, when you understand that your solidity is just a trick of forces, when you see that you're more accurately described as a pattern than as a thing, something shifts in how you think about yourself. You become less convinced of your own importance. You become less certain that you're a fundamental entity, a basic unit of reality. You start to see yourself as part of a larger pattern, a temporary organization of matter and force, a brief eddy in the flow of energy through the universe. And maybe that's something we need. Maybe we need to understand our fundamental emptiness in order to appreciate the complexity and beauty that arises from that emptiness. Maybe we need to know that we're almost nothing in order to understand how much meaning can emerge from nothing. Maybe we need to grasp the scale of our insignificance in order to genuinely appreciate the fact that we exist at all, that the universe has organized itself into a form capable of experiencing and understanding itself. Here's another thing that bothers me about this in a good way. If you think about it, the fact that we're mostly empty has profound implications for how we interact with the world. Every time you touch someone, you're not really touching them. You're being repelled by their electrons. Every time you push a button, you're engaging in an electromagnetic interaction. Every time you look at something, you're detecting photons bouncing off electromagnetic fields. We live in a world that is fundamentally made of empty space and forces, and yet we've built entire civilizations, entire ways of living and understanding, based on ignoring that fact and treating the world as if it's solid and substantial. And somehow this works. Somehow we can live our lives treating solids as solids, even though they're not. Somehow we can build bridges and buildings and computers that work exactly as if solidity were a real fundamental property. This is one of the great successes of science and engineering, the ability to predict how the world works without needing to fully understand why it works that way. We know the equations that describe atoms and electrons and forces, and we can use those equations to design things, to build things, to manipulate the world. But at the end of the day, we're dealing with patterns and forces, and those patterns and forces happen to be arranged in a way that resembles what we call solid matter. Think about this too. The forces that hold you together, the same forces that keep you from passing through walls, these forces are also responsible for chemistry. They're responsible for the bonds between atoms that form molecules. They're responsible for the ability of molecules to interact in complex ways. They're responsible for life. Without electromagnetic repulsion, there could be no chemistry, no molecules, no life. The very thing that keeps you from being able to reach through a wall and grab something on the other side is the same thing that allows for the existence of everything you care about: love, beauty, meaning consciousness itself. So solidity, although it's an illusion in one sense, is also the foundation of everything that matters to us. We need that electromagnetic repulsion. We need those forces to be strong and real and to operate at the scale where we live. Without them, we wouldn't exist. And that's a beautiful thought. That's a thought that makes me feel connected to the universe in a strange way. I'm not separate from this universe. I'm made of it. The forces that build me are the same forces that build everything. The emptiness in me is the same emptiness that fills all space. And here's something I don't think people appreciate enough. The fact that you're mostly empty doesn't make you less real. In some ways, it makes you more real. Because what you really are is not stuff, it's organization. What you really are is structure. What you really are is a pattern that persists. And patterns are more fundamental than stuff. Stuff is just what patterns are made of. Change the stuff, and if you preserve the pattern, you still have the same thing. You are, right now, not the same atoms you were 7 years ago. The atoms in your body have been replaced. Completely replaced, in most cases. And yet you're still you. Why? Because you're not really the atoms. You're the pattern that the atoms are arranged in. You're a living, breathing, thinking pattern. Now here's the real kicker, and this is what I find myself coming back to over and over. Patterns can be copied. Patterns can be transferred. Patterns can be communicated. And that's what consciousness might be. What if consciousness is a pattern? What if the ability to think, the ability to feel, the ability to experience the world, what if that's just a particular kind of organization of matter? Not some special substance that's fundamentally different from the atoms of the body, but just a particular pattern that emerges when you have a certain arrangement of atoms. If that's true, then in principle, you could copy that pattern. You could duplicate someone's mind. You could transfer someone's consciousness to a different body. Or maybe, if the universe is just information, maybe you could even copy someone's mind into the universe itself, preserving that pattern forever. These are science fiction ideas, I know. These are not practical possibilities, but they follow logically from the understanding that you're a pattern, not a substance. And maybe that's actually a more comforting thought than a soul or an eternal essence. Maybe the fact that you're a pattern, that you're made of empty space and forces, that you're fundamentally ephemeral and temporary, maybe that's actually beautiful, because it means that what makes you you is not some unchanging essence, but the dynamic process of being alive. You're not a thing, you're a process. You're a verb, not a noun. I think about this sometimes when I'm lying in bed at night, unable to sleep. I think about the fact that I'm mostly empty. I think about the forces that hold me together. I think about the atoms that cycle through my body. I think about the pattern that is me, this temporary organization that will eventually disperse, and instead of being disturbed by that thought, I find it comforting, because it means that I'm connected to everything. The atoms in my body have been part of stars, part of other living things, part of the earth itself. The forces that hold me together are the same forces that hold together the entire universe. I'm not separate, I'm not isolated, I'm part of a larger whole. And maybe that's the real lesson here. Maybe the lesson isn't that solidity is an illusion, or that atoms are mostly empty. Maybe the lesson is that separation itself is an illusion, that we're all made of the same stuff, held together by the same forces, operating according to the same laws, that the boundary between self and other, between you and the world, that boundary is much less solid than we think. You are mostly empty, and yet you are here, and that is everything.